Yeah, let's talk about views. So what is view is? View is a virtual table. So far we have seen sailors, reserves, boards. They are all, we can say logical schemas. That means they are going to be stored finally permanently. But sometimes you don't want to store the tables permanently because that's a waste of space. But you want to have them as virtual tables. That means you want to see them. Example, in the sailor table. So this subpart like sailor ID, sailor name, age. These three columns I want to see regularly. Okay, there is some set of group of people who want to see SID, SNAME, age, and they are not allowed to see the rating field. For them, don't create another table sailors. The reason, so already we have that values SID, SNAME, age in sailors field, right? So one thing is why to waste the space, correct? So that's why for that we create virtual tables. So we'll see how to create virtual table. For that syntax is create view. So we'll see the use of this view, create view. First we write the syntax, create view v. Let's say table name we should write here. Create view, the table name whatever you want to give as query expression. Here we should write query. Example. I am creating a view called only sailors with this information. How to do that? So create view, and what is the table name I want to give is sailors, a different one. So sailors public, that means I want to give only this information to public other than ratings. So the table name is, let's say, sailors public as query expression. How to get this SID, SNAME, age fields from sailors? For that we can write a query. So here we should write select SID and SNAME and rating, sorry, age from sailors. So in that way we can create a view. So this is the syntax for creating the view. When you do this one, what happens is table will not be created. Rather than that, this definition will be stored. So now your DBMS knows this definition. Whenever example you want to refer it, so you can refer from now onwards in another queries this table sailors public example. From now onwards, whenever you write a query like this, select, what is the column name, SID and SNAME, we can access from sailors public. That means this view is not limited to only this query. It is, extended to other queries also. That means we can use that somewhere else. Select SID, SNAME from sailors public. That's it. Where, let's say, SNAME equal to Raju. So if I do that, what happens is from this one, whenever you write sailors public, since your DBMS knows that this is the view, then it will go to this view and this query will be executed at this time. So this query will be executed and the result will be taken, and that result will be treated as a table here, and from that SID SNAME will be printed. Sir, I have a question. What is that? However, you are computing this, view, right? That means sailors public, you are saying that a separate table, which is result of this query execution. Fine. Why don't we execute this query first, and why don't we create a permanent table? There are two problems. One is wastage of space. The second important problem is why we don't pre-compute it. I will tell you. Example, you have some data like this in sailor table. SID, SNAME, let's take age, comma, rating. So if you have like this, some values are 1 to 3. A, B, C are the names of the sailors. Let's say age is 20, 30, 40, and ratings are 5, 6, 7. Correct? So when you create a view, assume that, let's say, whenever you write this create view sailors public, so table is created. What is that table? Sailors public. So when you create that, it contains three columns, right? One is SID, SNAME, so then age, correct? From sailors. So 1 comma A comma age 20, 2 comma b comma 30 and 3 comma c comma 40. Now see the problem. So suppose some values are inserted into this Taylor's table after this query. So if you create a table immediately whenever I write create view, so this will happen, one more table will be created. But what if I write 4 comma d comma something 50 comma 8? Then here also the value should be updated, correct? So that's why it is unnecessarily time taking. Whenever a new insertion occurs or whenever new deletion occurs, then that view which you computed, that also should be modified. That's why what people do is, for efficient implementation, don't create the table but remember the definition. Whenever people refer it, like whenever in the another query, if the table is referred, at that time this query will be computed and table will be taken. Okay, so from now onwards, suddenly, example, when you created view, this was the data 1a 2b 3c 4d. Okay, now if new tuple is inserted like this 5e 60 and rating is 9, so there will not be any problem for this view because this view is not created. That means the table form is not created, only definition is remembered by your your DBMS. Now if you write this query, select star from, what is the view name, sailors public, right? So from sailors public, if you write it, what happens is, by that time, see example, this is a query execution time. Let's say your query is going to be executed, then sailors public, so your DBMS will try to search in the tables, so it won't find because it is a view. Then it will go to view definitions, all the view definitions, it will see is there any view like sailors public, yes, then this query will be computed by that time. Okay, then here, so sailors public table will be computed now with three fields, SID, SNAME, age. So if it is done like that, then now see this new updation 5E69 also will be represented. Correct output will be, of course, 1A20, 2B30, so on, 1A20, so on up to 5E60. So this is the way this query will be executed. Okay. So this is a small story about views. So views can be used as tables, but they are not computed initially. So whenever you execute a query with view, example, this is a query which is using view as a table, by that time it will be computed. That is one thing you should remember. Otherwise, there is no difference between table and view. So table, I can say that every logical table like this, which is created using create table, will get permanent space in computer. But views will not get permanent space. That means they are just virtual tables, and on the fly while executing the query, another query which refers sailors public, they by that time they will be computed. That is one thing you should remember. And one more thing, you can use these views like tables. Wherever you want to use table, in the place of that you can use view, because view is also similar to table. That's why we can access view as a table. Okay, now we'll see one example of view. Create view red reserves as, select r.sid r.bid from reserves or boards B, where r.bid equal to b.bid and b.color equal to red. So this select query result will be stored as red reserves, but not immediately. So it will be, I can say that it will be stored temporarily. That means whenever we have a requirement, when you use that view, at that time that will be computed. So I can say that it is a virtual table. So that virtual table is red reserves. So red reserves that contains two columns, because your query contains two columns, SID, BID, from reserves and boards. So where r.bid equal to b.bid, see r.bid 007 equal to 007. That's why this tuple will be taken. From that r.sid, what is that r.sid? 1, and b.color, so red, yes, b.color is red, then b.bid 007, 1007, satisfy this condition. 1008008, you see, so r.bid equal to b.bid, 008 equal to 008, and it's a red color board, b.color red, then this combination will be taken and you get 1008. Similarly, if you execute this query, so do you get anything? 2009, see here, r dot bid equal to b dot bid, 009 equal to 009, but b dot color is not red. So only red color boards are 007 and 008, only their corresponding SIDs will be taken. So that's why only one person reserved red color boards. There is, of course, 3 also reserved a red color board, you see, 3007, 007 red. Then when r dot bid equal to b dot bid is computed, r dot bid 007 equal to b dot bid 007 and b dot color red. So this combination also will be taken and you get 3 comma 007. So this is the computation, but immediately it will not be done. Already I told you it is a virtual table, so it will be computed on fly. Now this is just view definition. If you write this view definition, nothing will happen, this table will not be created, but when you use it, it will be created. Example, if you write this query, select, I want SID from red reserves. So you can write this kind of queries, red reserves where, that's it. Let's say there is no condition or anything. So if I write this query, what happens? Simple. Since it is a view, now this at this time, example at 10 o'clock you are executing this query. So 10 o'clock your DBMS will see red reserves, then it will come here. Let's say that is the best possibility. I am not saying that always and every DBMS will do that, but it is the best possibility. The best possibility is now computing it, red reserves. So that will go to view definition of red reserves and this query will be executed now. So you get updated information. Meanwhile, when you created view, so there may be only few tuples in reserves and boards, but later maybe after your view definition, so some other tuples may be added, but still when you use it at that time, so the current reservations, current boards will be taken. So updated reserves and updated boards. Now if you execute this query, whatever the result you get at that time, so that will be treated as a table. So that will become red reserves for this query. So in that you are printing SID. So 1 comma 1 comma 3 will be printed. Example, see the situation in this model. If really your DBMS follow this model, then that will be the best idea. Most of the time, like 90% of the DBMS use this model. Example, 8 o'clock you created this view, okay, 10 o'clock you are executing this one, but this is, let's say, table at 8 o'clock, this is table at 8 o'clock, but what can happen is at 9 o'clock some new data may arrive, that is, let's say 00, I'm talking about 9 o'clock. 9 o'clock some user might insert some information in boards, that is, let's say 010 red color board and its name is D, and user might add one more information in reserves at 9 o'clock, that is possible, that is nothing but 4 comma 010 comma let's say 7 comma 8, something like this. Then now you see the situation, when at 10 o'clock when you execute red reserves, because that time this query will be computed, then at that time 4010010, so 4010 also will be added to the result, because we are creating this table at 10 o'clock. By that time they are available, so new data will be included, so that's why there will not be any problem, correct? But if you pre-compute it at 8 o'clock, okay, when view is created, if this table also is computed, let's say, then there are lot of problems, because updation problems. So whenever the corresponding tables of the view are updated, this also should be updated, it's time taking, right? And it will lead to inconsistency problems if you don't do properly. That's why remember, view is a virtual table that is created only when it is used. That's it. Let me introduce you two more miscellaneous operators. One is like operator, second one unique operator. So let's begin with like operator. So when we use like operator, so this like is specially designed for pattern recognition. That means you have a column, so that column has string. Example, sailor names. So you want to find out sailor names whose name starts with, let's say, R, otherwise whose name ends with B. So such kind of, because you don't have exact name with you, but you want to search for the sailors. So with some limited data you have, usually in Google you do, right? So you just type keywords, automatically data will be fetched. Similarly, like operator also, it's a pattern recognition operator. That means, example, you have a table with a field called sailor name. Let's say this is sailor table. So there are some people: Raju, Rani, Rakesh. So 5 days back you met someone, so who is your friend. So that person name you did not remember. Example, let's say 5 days back you met one sailor. His name starts with R. You know that you know that he is Raju, but you are not able to recollect his name. But you know that it sounds like Ra something. Then what we can do is we can use like operator and we can search into sailors. Search into sailors such a way that where sailor name like, so we use like here, like R. That means you know that your friend's name starts with R, but you don't know the remaining letters. Then we can write a query like this: select, I want to see all the sailor names, select S name from sailors. See, where to use like is in where class. Where column name, what is the column name? So this is syntax. Column name is S name like, simply. Where S name like, then we have to write this quotes. Okay. So in this apostrophe, we should write whatever you want. So you know that your requirement is your friend's name starts with R and you don't know anything more than that. Then you write R followed by, after that what? You don't know. If you don't know, then we use a symbol called percentile. Remember, so I am going to use percentile and underscore. So underscore is for exactly one unknown character. Percentile means, so some set of characters are unknown. Example, whenever I write R percentile, that means your S name starts with R, first letter is R, after that percentile. So after that there are some other characters. So this represents some unknown string. Underscore represents some unknown character. Okay, so unknown character, unknown string. So when you write R percentile, you can imagine it like, so that your friend's name starts with R. After that, there are some 0 or more characters. Okay. So when you write this query, what happens is, so all the strings which starts with R and which contains some more characters will be printed. Anything. Example, there is a sailor called R. He also will be printed, because when you write percentile, so that your SQL or DBMS understands it like this. See, R followed by some 0 or more letters at right side, correct? So any name with R first, after that some 0 or more characters at right side will be printed. That's why Raju, Rani, Rakesh and R will be printed. But Suresh will not be printed. Why? Because this R in Suresh, this R is in between, right? Because you are searching for names which starts with R. For that, this will be the syntax and Suresh will be discarded. Later from them you can fetch whatever you want, correct? So this is the idea about using percentile. So when to use underscore? Example, you know that, so your friend's name is, let's say, Raju, but you don't know the spelling, but you know that first letter is R, third letter is J. That too you remembered. Then we can search in a sophisticated way. So what you can do is, you know this R and you know this J, then you write like this, where S name like apostrophe followed by R, first letter is R, and you want to say that third letter is J, right? So second letter you write underscore, then one letter will be counted. So first letter R, second letter don't know, third letter J. After that you don't know remaining thing. Let's say if you don't know the remaining thing, you write percentile. So when you write it, it will, your DBMS will search like this: any name who starts with R, second letter underscore means second letter here, because you wrote in the second position. So that underscore is nothing but second letter is anything, followed by third letter is J, first letter, third letter, second letter is anything. Now after that percentile. Example, here you have Roja, one sailor. Now that Roja also will be printed because of this like operator, because this Roja also will match this condition. First letter R, second is underscore, that means second letter can be anything. Yes, O also possible. Third letter is J, yes, perfectly matching. Then percentile, after that some sequence of characters, correct. Next, so if someone is Rojesh, also will be printed because first letter is R, correct. Underscore, yes, that means some next another character followed by third letter is J followed by percentile. Percentile means some sequence of characters. Yes, so Rojesh matches it in that way. So we can get all the names which are using these hints. Okay, so which are having these properties. So remember, we use underscore and percentile. Using that we can write sophisticated queries to search some of the sailors. So we'll see one more example. Example, I want to find out sailor names whose name ends with something weird letter Z. So you know that your friend's name ends with Z, you don't know anything else, then how to write it? So I don't write complete query, so only the essential syntax I write. In the where class you write like this, where sailor name like. Now we'll try to generate the code for it. So your friend name ends with Z. What about other characters? Do you know how many characters we have before Z? No. Then directly we can use percentile. That means your friend name starts with something, percentile, and later Z. So when you do this one, so what your DBMS understands is percentile, some set of characters followed by Z. Yes. So any name ends with Z, then it will have some set of characters. Sir, what if my name starts with Z, ends with Z? Example, the friend name is Z. Will it be selected? Yes, because percentile means 0 or more characters followed by Z. Yes, so this Z can be seen as some 0 characters followed by Z, right? Yes, so some 0 or more characters, percentile Z. So yes, it will definitely print Z also. Okay, so in that way we can print any strings. Now we'll see one more example. Example, I want to print out all the sailor names who have exactly 3 characters. Exactly 3 characters, but that characters can be anything. Then like something like Bob, otherwise something like cat, everything, all these strings I want to print. Finally I want to print sailor names whose name has exactly 3 characters. For that what I do is I write like this, like. Now you understand the usage of underscore operator, like. So one anything, second letter, third letter, anything. So that's fine. So each underscore represents one arbitrary character. So these 3, that's it. If you write it, all possible 3 length strings will be, which are part of your table, will be printed. That's it. Now example, I want to have this requirement. I want to print out all the sailor names who start with B and ends with Z. Okay, but exactly 4 characters I want to have. I want to print all the strings with 4 characters. First character is B and the last character is Z. Then how to write it? So you write where sailor name like apostrophe, and since it should start with B, then mention it, followed by exactly 4 characters overall, right? Then second character can be anything, third character can be anything, fourth character should be Z, right? Then only it will end with Z. So this is the idea about using underscore. So using underscore and percentile, based on the requirement, we can easily write any problem, like otherwise any query. Let me introduce you unique operator. We use unique operator in where class, like exist operator, and the query's result, otherwise this where condition depends on this subquery. That means after unique we should write subquery, remember. So that is the way we use unique. So now this unique depends on this subquery. Example, this subquery contains only 0 or 1 tuple. Okay, after execution, then unique will become true. That means where unique of, unique means the number of tuples should be 0 or 1. okay, not more than one. If at any time in the real world, I mean not only in SQL, anywhere, whenever I say unique, then that means that number of like values should be 0, otherwise 1. Okay, so here this table contains more than one tuple, then unique will become false. Unique will become false. We'll see with one example. Example, see this query, select s.sname from sailors as where unique followed by subquery. That is the syntax. Now here if you see carefully, we are using a variable s, that's why it is a correlated nested query. In correlated nested query, how we evaluate the query? We take the outer query variable first tuple sailor. On behalf of this tuple, generally we execute, right? Step number 1, step number 2, step number 3. In the step number 1, take the first tuple, which is nothing but 1 comma a. Then where, come to where class, unique. So unique depends on this query. Let's execute this query and we'll see the number of tuples. So blindly execute this query. Select r.sid from reserves r. So from reservations, take every tuple. So you know, whenever you have a query, how to evaluate? Step number 1, step number 2, step number 3. Let me execute it. So from reservations where r.sid equal to s.sid. Select all the tuples where r.sid equal to s.sid. What is s.sid? Because this s.sid is coming from outer query variable. So at this moment that is 1. It is like now select reservation IDs where r.sid is 1. So r.sid is 1, correct? So we have to print that. 1 will be printed. This is selected. Next tuple. So r.sid equal to 1. Yes. So one more 1. Next 2. Is this r.sid which is 2, is it equal to 1? No. Then this tuple will be rejected. This tuple will be rejected. So only 2 tuples will be selected in this query. Okay. So now the question, number of tuples whatever you got, are they unique? No. They are more than 1. So asking where unique of this is false. That's why condition will become false. This will be rejected. Now later we will go to the second tuple, we know that, and we do the same. If I substitute here s.sid 2, then we'll see what is the output of this query again. Select from the reservations where r.sid is 2. So there is only one tuple and that r.sid will be printed. So this query's output is only single tuple, right? So it's unique. So that's why condition will become true and 2 comma b's name will be printed. That is b. So I'm writing output. In output we get b first. Then 3 comma c will be substituted. That means here s.sid is 3. Then at that time, so reservations where r.sid is 3. Only one reservation. Then output will be only one tuple here. So this will be printed, right? So what is the name? C. Later 4 will be substituted. Then you get what? Is there a reservation with 4? No. Then the number of tuples selected here equal to 0, right? So empty table. When you get empty table, my question, is it unique or not? Unique means number of tuples are 0, otherwise 1. Yes, 0. So this will be selected. So output is b comma c comma d, but not a. So similarly we can use not also here. If I write not unique, then the right side the number of tuples should be opposite. That means so far we have seen that number of tuples should be 0 or 1, right? Whenever I write not unique, then the number of tuples should be more than or equal to 2, otherwise more than 1. So whenever you have more than one tuple here, then such tuple will be printed in the outer query. That's it. So exactly opposite to unique. So if you don't understand sometimes not operator, so what you do is execute this query with unique first. So execute where condition with unique. Then after that, if you get false result, then not unique will become true. So if you get true already, unique becomes true, then not unique will become false. In that way, you can do the flipping of the result. That's it. Okay.